One of the benefits for using equipment of the level that we have, of the precision that what we use, is that we are able to predict leaks before they actually happen and affect the process. We can determine through calculations and through history and just through engineering that a problem is on the way.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. In today's episode, we'll be speaking with Adam Dupps, general manager of Masterleo, and Bryan Rumrill, director of sales and business development at Rodem. They're going to be telling us all about integrity testing, what it is, its benefits, and much, much more. So, without any further ado, let's get on to the episode. First of all, thank you so much for taking the time to talk to us today. And we're going to be talking about integrity testing. But before we get into that, would you two mind introducing yourselves? So kind of tell us who you are, what you do, any information that you think would be useful for our listeners and viewers to know.
I'm Adam Dupps, the general manager at Masterleo. We are a testing and calibrations service provider, essentially a field service entity. I've been in instrumentation for 14 years. I have degrees in electromechanical engineering and an MBA.
I'm Bryan Rumrill. I'm the director of sales and business development for Rodem. As far as what we do, we are a distributor of equipment and systems for processing, primarily based on the food and beverage, pharmaceutical, and personal care products.
Let's start off with the absolute basics. So what exactly is integrity testing?
So integrity testing is a non-destructive method for predictive maintenance to ensure the structural and functional integrity of heat exchangers.
It's part of a generally accepted good maintenance plan for making sure that existing equipment is running as it should. And we're trying to predict when we might have problems down the road so that we can address them sooner than later.
What are some reasons why a manufacturer might need or want to do integrity testing?
The main reason, you're looking to ensure the efficiency and safety of your heat exchangers. You really want to be able to identify leaks, any kind of gasket failures. You're wanting to prevent contamination and any kind of product loss.
Yeah, and generally speaking, the customers or the people that would be interested in integrity testing manufacture something, and the equipment that they would be testing would be part of what you use to make that product. So it's a way of making sure that we can make product the same today, tomorrow, and in the future based on equipment performance.
So that kind of feeds into the next question, which is what are some of the benefits that come with integrity testing?
So benefits, you're looking at a proactive approach to be able to identify issues early on. You're wanting to be able to mitigate some of the supply chain issues where your heat exchangers aren't necessarily off-the-shelf items. Is where you're seeing long lead times on those things. You're able to plan for repairs and replacements more. You have optimized operations, things operating at 100% efficiency or close to it, rather than losing energy and product. You're having reduced downtimes, more uptime. So.
Yeah, and I think a lot of that also plays into many companies' key initiatives like sustainability. We know that we have resources that we want to most efficiently use, and we also don't want to waste utilities and things that are bad for the planet.
So then efficiency is one of the end goals here.
Efficiency is an end goal, and minimizing impact on the world around us is also an end goal.
So then what types of systems or applications can benefit from integrity testing?
Integrity testing can be used on a lot of different things. The main ones, you're going to see plate heat exchangers, tube heat exchangers, and then any kind of pressurized vessel. Some of the larger vessels it's not going to be reasonable for, but many of the smaller ones we can.
Yeah, we've worked with some customers to do things that were not really what integrity testing was primarily designed for, but We primarily use it, like Adam said, to test heat exchangers, where we've got a product on one side of a piece of metal and a utility on the other side of the piece of metal. We don't want them to mix for many reasons, like we've already touched on. But another area that we've seen usage of integrity testing equipment would be to test for leaks in process piping, in tank jackets, and actually tanks or vessels themselves. So unintended uses, but they were equally beneficial.
And what kind of, so I know this can be used in the food and beverage industry. Is it used in other industries as well, or mainly food and beverage?
Food and beverage is a big player, but also pharmaceutical. Anywhere you really have a heat exchanger, which is quite a few applications and industries.
I think there would also be industrial and chemical related usage or potential. The industry we focus on is more related to clean processing, which would generally be food and beverage, pharmaceutical, and personal care products.
All right. So then speaking of heat exchanger testing in general, what's the difference between integrity testing and other types of heat exchanger testing?
Integrity testing uses it's called the hydrogen gas method. Uses a mix of hydrogen gas and nitrogen gas. It is pumped into one side of the heat exchanger. You have a compressed air, and then the testing system pumped into the other side, piped into the other side. The gas circulates through the heat exchanger, and if there are any cracks or holes, any kind of gasket failures, the system will detect that because the gas will leak out through those. The system takes measurements at 3 different points, 3 different pressures, and that way we can ensure accurate results. We have a technician who uses a wand sensor to detect any kind of a gas leak external to the vessel. And then the technician will review their findings and generate a report based on that.
In layman's terms, we're putting a gas on one side of a piece of metal and we're sniffing for it to pass through on the other side. And over the years, there have been different ways of doing that or different methods. The one that we've used is the hydrogen mix technology. And one of the benefits of that, of course, is that hydrogen is the air that we breathe. It's not a finite element, so we're not going to run out of it.
So getting kind of back to that sustainable aspect of the technology as well there.
Right. And sustainability is great as long as the technology works. So we aren't giving up. We're actually utilizing a more sensitive or accurate technology using hydrogen than some of the others that have been out there for a while.
So can processors do integrity testing on their own, or does a third party need to come in and assist them on that?
I would say yes, they could do it. It's generally not cost effective for them to invest in the equipment, especially if they're only performing that testing on an annual basis.
There's a skill set involved with using a different piece of equipment or a new tool. So it's beneficial to use if someone is performing the test, it helps if they've done it before and they do it right. Also, I think that much like in school, creating your own test, if you're being graded by someone else, you tend to believe the results.
So that they carry a higher credibility.
Yeah. If you have a third party testing, credibility is generally high.
Third party testing reduces the risks and liabilities that a company might face. It's also an integral part of any quality assurance system.
That makes sense. Okay, so then it's technically possible to do it yourself, but it's probably better for many reasons to have a third party come in.
I would say yes. The test itself generally takes about 15 minutes per plate or
Section.
15 minutes per section. Give or take a few minutes, but yeah, it's a pretty quick process.
Yeah, and by section, that means some heat exchangers have multiple sections. So Adam was not talking about one plate or the gap between two plates. He's talking about an entire section that would be interconnected. So even if you connect to a section, that would be a couple of plates, that could be 200 plates. As far as the test, how long it takes to do the test, it's pretty quick. And generally speaking, one test is actually three little tests. and we're measuring for consistency across those. So even though it takes a short time, there's a lot that happens in a short time. A different area that we've used this equipment already was for a tubular heat exchange system. And tubular systems can consist of one tube inside of another tube, or it can consist of a bundle of smaller tubes inside of a larger outer tube. They can be very difficult to test. It's difficult to do a dye test because you can't visually get in and see leakage or dye passing through a hole. So gas testing in this case was really the only effective and realistic way of testing a large section of tubes with bundles, right? And minimize downtime. This was for a customer that makes nutritional drinks, and it was very important for them to make sure that what they provided their customers, all of us would be their customer, a healthy and nutritionally accurate product without cooling or heating media mixed into it. So without glycol, hot water, or steam. This was the only effective way of doing a test on that type of equipment.
So then this kind of technology is really, really made for that kind of product then, it sounds like.
Versus what's available elsewhere, it's the best technology.
A particular brewery had shell and tube heat exchangers that they needed to do testing on. They had a shutdown planned for it was a very short time frame. It was about a 2-day turnaround, and we were able to rearrange some of the schedule, and then also acquire all the equipment, and then have a technician on site in that time frame. So it was within about 48 hours we were able to get somebody on site and prepared to do the testing. That's generally not recommended, but the capability is there for emergency services.
And when we talk about integrity testing, just in general, I try to come up with examples for people in my family to talk about what we do for a living. And I need to break it down for them to be able to understand and be interested in what I'm talking about.
Right. That's always a tough question. What do you do when what you do is rather complicated?
Exactly. So when it comes to using the types of tools that we're talking about today, I would equate it in some ways to going to the doctor and having the doctor check your arm or your leg where it hurts and trying to assess whether you got a break or not without using an x-ray machine. To use integrity testing equipment is a way of seeing things that you can't necessarily see with your eye, and that you can't necessarily watch something leak through, because leakage, porosity, and holes can be very small. So when you have good equipment, good diagnostic equipment, it takes guesswork out, and it also is sort of a litmus test for pass, no pass. That's right. One of the benefits for using equipment of the level that we have, of the precision that what we use, is that we are able to predict leaks before they actually happen and affect the process. So by sniffing for really small molecules passing through a piece of metal, we can determine through calculations and through history and just through engineering that a problem is on the way. We can detect it before it arrives, which gives us time to plan for it. And as Adam referenced earlier, with all the supply chain issues that we've experienced over the last couple or few years, it helps if you can put things on order, purchase things before you need them, because they are generally not available today or tomorrow.
So for places that are not using this kind of technology, what do you think is standing in their way, or what do you think is preventing them from doing that?
That's a good question. The main point that I see there is they just don't know about it yet. There's a couple of older technologies that are used, dye penetrations used, radiography where you use x-rays. electromagnetic fields. They're using those technologies. There's costs associated. There's longer downtimes and safety precautions with the X-ray equipment. And then with the dye penetrants, there's cleanup and residues after that process is finished. So one thing that we can do is eliminate some of the downtime, eliminate the mess, the cleanup, and then eliminate some of the safety precautions that are associated with the other technologies.
Yeah, it's a generally speaking, the equipment used to do this type of testing is it's a real investment. It's not inexpensive. It's a newer technology, and with regard to benefits, it's the least invasive, I would say, to do testing for leakage or upcoming potential leakage. So it's one of those where you could hook up, test, and then reconnect process lines and be back up and running much more quickly than other more traditional testing centers. Right. I think it would be accurate to say that a benefit of doing regular integrity testing is that we can track the results of tests over time, and we can trend. We can measure or trend issues that we see, and some of this type of testing can also be useful in maximizing or adjusting the process in other areas so that you aren't seeing the same wear results or the same portions of your heat exchanger, for example, that are seeing wear or they shouldn't. So some of this type of testing provides the ability to track the process and look bigger picture.
Reports generated give you a good insight into how your equipment is operating. With that information, you're able to plan and predict failures. You get to a point where, we recommend an inspection on an annual basis. So instead of a month, 2 months down the road, you have a failure, you have an outage where your heat exchanger is all of a sudden leaking product all over the place. You now have a tool to predict that months in advance.
So as other areas where we like regular integrity testing would be beneficial, would be to track the performance. It would be to schedule predictive maintenance or to alter cleaning methods, or we talked about adjusting our process to increase the longevity of equipment. Those are all great areas, but we also, as a manufacturer, one of your primary concerns is making products as quickly as possible, as efficiently as possible, and as cleanly and accurately and repeatedly as possible. Nobody wants a recall. That's a bad thing. So this is a minimal investment to help protect against recalls. Also, manufacturers want product consistency. So if we're using thermal equipment like heat exchangers as part of our process, we want to make sure that we don't overcook, change colors, change the look, change the taste, change the smell. And we want everything to be consistent. So this is another means of maintaining consistency.
You just come up with that.
I just made that up. It is true though. So in the food and beverage industry, the primary testing methods that we've traditionally seen have been the dye penetrant test, where we are literally placing dye on one side of a piece of metal and measuring how much or if any of it leaks through. And that's a visual check. When you consider passing through small cracks, crevices, holes, and plates, there is a size at which water or dye will not pass, but the gas will. That helps us to be able to more adequately predict what the future looks like. I'm the chatty guy, just so you know. They can't figure that out.
No, it's good to have a balance. So before we wrap things up, is there anything else you'd like to share with us, or anything you want our listeners and viewers to take away from this episode?
Integrity testing for gasketed plate heat exchangers, shell and tube heat exchangers, represents a proactive approach to predictive maintenance. It holds an immense value for the food and beverage processing industry.
integrity testing is another tool that processors have to keep their equipment running efficiently. And it's cost effective with minimal downtime, high accuracy, and allows for potentially just more consistent processing and consistent better products. So,
Okay. Well, then
thank
I.
you
Oh,
for
yeah.
letting us do this.
Yeah, absolutely. That's what I was going to say. Thank you so much for taking the time to talk with me about this.
Thank you.
Huge thanks to Adam and Bryan for taking the time to talk to us today about integrity testing. If you're listening to the podcast and would like the chance to watch it, head over to the Pumps and Systems YouTube channel to see the full video version. That's going to do it for today. Thank you so much for listening or watching, and we will see you next time.